Good morning. Welcome back to the JagCorner. I'm probably going to take a little bit of time to see if people stream in here or drop in. I think I have everything set up. We're doing something a little bit different today. We are programming, but I'm diverting, or I'm shifting gears from Crescent Memories over to something a bit smaller. Give me just a second. If you're there lurking, please shout out in the chat and we can begin talking. Yeah, so I think I got everything set up here. I don't need that open. Yeah. Okay. This might get in the way. We'll see. Excuse me. Daysite user, good to see you. Good morning. Yeah, is it afternoon for you? Is it getting late? I get done with work, getting ready to go to bed, relax. Well, today's stream is going to be pretty relaxing. Maybe a little too much, we'll see. It should be interesting. Let's see here. Let me hop you over to the browser. Because today, I don't know if you're on the Atari Age forums, Daysite user, but somebody posted Retro RGB, and I don't know if that is the actual, there's a company or something, right? Retro RGB. Yeah, don't they do RGB solutions for Mr. Update? Yeah, so they do stuff. Oh, I wonder if it's let's jump over to their YouTube really quick. Getting started. I've not seen this yet. Yeah, they just posted yesterday, and they're looking for tools to test hardware or audio and video on the Jag. And there are solutions out there. There's the original solution, which was and we'll take a look at that here in just a second, that Atari's test cartridge, their diagnostic cartridge, which I assume they were running in the factories. They just drop that in, run it through the tests. Oh, everything's working. This one's QC'd. Pack it up and ship it out, that kind of thing. But I don't think there's been much since then. There's been disparate ROMs and things that people have put together. For example, Matthias Dahman, he did the controller tester, which is what we'll be working on today. We'll be building our own controller tester, which should be interesting. I only know enough about the controllers to get games to play and do basic things like button locking, that kind of thing. And we're going to have to look at some of my code for other things in order to get that working. But I'm going to try starting from scratch. We're going to look at the documentation and see if we can figure it out. I've had to do it like 2 or 3 times and I can never remember because I don't do it very often. But anyways, I assume this is the guy that's on the forums. And he's done some interviews, podcasts. I think I've seen some of his videos before. So anyways, so he's not completely illegitimate. And anyways, I saw this as an opportunity. Hey, this is something I can break away, try some new things out, learn some things. I actually did learn some things about audio. Doing this, how to properly, well, I know how to properly convert samples. It's setting up the code so it plays it back correctly. So learned some things with that. That was great. And he talks about this this 240p test suite, which I've seen before as well. Let's jump over to that really quick. I've seen this on other platforms, and obviously there isn't anything for the Jag, and we're not building something as thorough as this, and maybe we should. I don't know. I guess we could. Oh, look at that. Our Ntsc levels regarding contrast and brightness and appropriate colors as well. When in PAL mode, EBU color bars are shown instead, since setup starts at 0 MV. Oh, that's something we may need to do here. Seeing these people obviously know a lot more about this than I do. But anyways, this is they got lots of cool test patterns here, and maybe one day we'll do the same thing. I don't know. Stripe test, lag test. Oh, that's cool. Sign needs to be connected at the same time, one being a CRT or display with a known lag as reference, and the other the display to test. Using a camera, picture should be taken on both screens at the same time. The picture will show the frame discrepancy between them. The circles in the bottom help determine the frame even when the numbers are blurry. The Sega Genesis version of the test can be used with a Nomad as the reference display. Oh, that's cool. Oh, all sorts of cool stuff here. Scroll test. We may have to do something with that as well. Grid scroll test. Horizontal stripes, checkerboard, backlit zone test. Yeah, I may turn this into a little project and go through and recreate as many of these tests as I can, based on their documentation here anyways. Just for fun. Oh, come on. Anyways, so specifically it was asking for just a few things. An all-white screen 100 at 100 brightness, a 100% color bar screen, and I'm not sure exactly what this 100% color bar screen is. I just figured color bars are typically at 100. I've never seen them otherwise in other audio-video systems. This would accomplish the exact same thing as the all-white screen when testing voltage, but could also help with color checking. And then a sound test where you can select left, right, and center to test audio output. In a perfect world, we'd have the 240p test suite, as well as the MD Fourier, I assume that's how you say that, ported to every console in existence. But that's a lot of work. and I'm hoping someone here knew of basic tools that that already existed. Or maybe someone could be gracious enough to just write sorry, a single ROM with either the 100% white screen or 100% color bars. I'll be happy to host the file if needed and would gladly write a post to promote it. Thanks in advance for any help anyone can provide. So, man, I get all these spammers. Buckmug. See if we can get rid of that. Boom. Gone. Anyways, so people got talking about it a little bit, and then Zero Square, he posted this little video of the Atari Jaguar factory test cartridge, which I believe you can get through Ntsc Computer Visions, if I remember correctly. Can get it through them. Let's take a look at that. So it looks like it's just going through some colored screens. Oh, and look at that. There's some color bars. More colors. Oh, and then a Cybermorph. System test May 3rd, 1994. Awesome.
Good luck.
Now, I wonder if this is actually in the game somewhere. This level, at least. Be cool if this demo was still baked in to the game.
Done.
See what else it does here. About halfway through. More color bars. A white screen. Then... oh, we have some more color bars and an audio test, it sounds like. And then that classic Parrot's picture, which is pretty cool. Here, I'm going to pause it. We're going to go take a look for that. Wiki color bit depth. Believe color depth. Yep. Seems like that is a classic image. Maybe it's not on the wiki anymore. They used to have it. Maybe they've swapped it out. Let's see your color depth. Oh, cool. They mentioned the Atari ST's low resolution here, right there. That's cool. Maybe it's not there anymore. I thought that there was 8-bit color. Well, maybe they took it off. It seems like there was a point where they had that parrot picture, because that was used for a long time to show different bit depth. I assume it seemed like I'd seen it, over the decades, being used in different places. But, anyways, back to the video. Didn't want to sidetrack too much there. Parrots, parrots, parrots. And then it does a controller test, and I assume the free means, oh, now it's time to actually test it. Looks like they're just testing a single controller. So today what we're going to be doing is building something similar to this. What I would like to do is build it for 2 team taps as well. And I'm going to have to dig out some stuff in order to do that. I do have my team taps here. I've tried one of these before, and it seemed like, in case you've never seen a team tap before, and it seems like one of them was having issues. So I don't know how far we'll get with that. We'll at least do 2 controllers today for our software test suite. But before we get to that, let me show you. Let's see here. What would be the best way? Let's go to Kate. Yeah, there we go. Let me show you what I have so far. So I have this cool, these cool boxes with text in them and a fading background. That's about it. In the future, I'd like to deck this out some more, but the tests are more important right now. So the way I'm doing the text in the boxes is the removers library has a built-in console display. And so it's really easy to just say, hey, open a console, and then just type some text into it. And I'll show you that. And, well, let me show you that right now. Let me turn Kate off. Or not Kate, Virtual Jaguar. Oh, we gotta turn off studio mode. There we go. Okay. In fact, I'm just gonna kill that. Turn it back on. Okay. So, for example, well, right here, I have this debug console. So if I uncomment that, we'll see up at the top, there'll be a new black box, or at least there should have been. Let's see here. Maybe we have to type something into it. So fprint f. We're printing to a file in memory, I assume, and then you tell it which console you want to print to. And then you give it some text. Hello world. Just like that. Let's see what comes up. There it is. So hello world, it prints it out. Yeah, so it's just a console. And very useful for debugging things. Glad that's in the removers library. I've used it many times. And it's been pretty useful for this project too. I've had to and this may be beyond most people's scope, but I had to add in so right here, this close console function. So he has this in his source code, but this structure, this data type here, isn't accessible outside of the source file. It's local to specifically the console C file. Which means I can't use this close console function. So what I had to do was just duplicate that inside of my source file. So there's the type definition for console, and then which all it does is it gives me access to the sprite that shows the console and all that stuff. But importantly, it allows me to actually close the console when we're not using it. So when I'm going between things. Anyways, let's bring up Virtual Jaguar again. Okay, so we have our consoles. Our first test is a position calibration, which is pretty simple. You've probably seen this in some Reboots games. I know they usually have a screen calibrator. And what this does is it changes the X and Y position for the screen buffer. So what that means is everything is painted to the screen buffer. So every sprite is painted to the screen buffer. And so if you change the XY position of not the screen buffer, the display buffer. I got to be specific about that because in the removers library you have the display, and then inside the display you can have screens, and inside those screens you can have sprites. Or the display has layers, and then you can have screens and sprites, other screen buffers. Gosh, I can't keep it straight. Anyways, so yeah, you can set your position here. It seems like for Virtual Jaguar it's like 20 or 19 and 1, something like that. I was testing this on my CRT, and my CRT is pretty bad. I noticed with so it's the image is skewed, so it kind of skews and scales weird. I don't know if there's any way I can actually fix that, at least easily. I may have to get an actual technician to take a look at it, which I do know a technician. I'm a little worried about how much that might actually cost, because I know working on CRTs is quite dangerous and not a skill that's widely known anymore. But anyways, hit Option to bounce back out. We have color bars, just a simple set, Ntsc color bars. Yeah. There's that, and currently only for Ntsc, pretty sure, because what we were just reading on that wiki page for the 240p test suite is they have a separate set of color bars that pops up if it detects that it's running PAL, which is a whole can of worms that I don't know if I want to get into. maybe we'll do something with that. And then we have a white screen, and I actually have my fade routines. They just fade up. So I have a global variable that I just switch the color out, and I have functions that are just checking, oh, if that changes, we need to change to that color. So yeah, CRTs can be tricky. Good thing you have someone with the skill. They are harder and harder to come by. Yeah, and the guy I know, he has some serious health problems right now, and so I don't know how much longer he'll be around. I kind of hope he sticks around for a bit longer, but he's getting pretty old as well. He actually I'm not going to use any names here because I haven't gotten his permission, but he was actually an Atari technician for a long time. It seems like for at least 10 years. He was working on Atari 2600s and Atari 8-bit computers. I think he stopped sometime before the ST or during the ST's life. I think. I've only had this conversation with him once. Be cool to get a little more information from him. Be cool to write some of that down. Maybe I should get with him and do an interview. And get that up on JagCorner. I think that'd be a good interview. So color bar, the white screen is cool because it fades up. And right now I'm doing the fade. I have for each color channel is a different vector, and so it's checking those all independently before it changes the color. And so that's why you kind of have a little bit of weirdness. You'll see it gets a little more green and a little more blue as it gets up because it's doing those independently rather than together. It's not creating a linear vector for all three of those so they're matched all the time. That's okay. And then this is right now the coolest part of this test suite is the I think he has some interesting. He's told me some interesting stories already. With we have an arcade and an original Asteroids machine, and he used to work on those as well. And he's like, man, I haven't worked in one of these in like 20 years. And he got in there. He knew exactly what the problem was. We were having some audio issues and some contrast issues, and so he's able to go in there and fix some things and get it running again. Really cool. Very cool guy. Man, I wonder if he'd be willing to go on camera. He's been on camera before for some other things, and so that I've worked on some other productions, and so he may be willing to get on a live stream with me or something, and we could just chat about that. That'd be fun. Anyways. Okay, so the sound test, and I did a little bit of an audio test before the stream, so you should be able to hear this. In fact, I'll probably go turn the volume up here. But it's used to test left, right channel, and center. So let me go turn the audio up. That should be plenty loud now. And what we're going to do now is you can fade it left. You can fade it right. Pretty cool. And then on the controller, you can use 1, 2, and 3. So 1 goes to left, 3 goes to right, and 2 goes back to center. So that's that test. And the music was just from opengameart.com or .org. Might be .org. Could be .com. Can't remember. Anyways, so there's that. Today we're going to work on the controller test, which should be interesting. Might be a little bit boring. But it should still be good. Let me turn the volume back down on Virtual Jag. Of course, we won't be hearing much audio from this point on. So, in code, it's kind of a mess right now. I just have a state machine going on. So I just have a while loop that just runs a switch case statement that gives us a state machine. We're just telling it to break out of the state and go to whatever state it needs to go after that. And so we have right now, actually, let me bring that back up. If we go to the controller test, it's just a not available. Same thing with screensavers. I was thinking we may do the screensavers as well if the controller thing turns out to be a little bit too difficult. There's a program I did very early on when I first started programming around 2011, 2012 that I actually lost the source code for, but it'd be cool to recreate that. screensaver here, and so we may do that. We'll see. I'm not sure. We're going to start with the controllers though. And we may actually break out into a different function, a different source file for the controller state. We'll see. We may just build it in here too. Okay, controller test right here. So this is where we're going to be writing our code. It's inside this while loop. And what we're going to do first, I'm not going to bring in any graphics, at least not right now. We're just going to procedurally create some graphics with some screen buffers. And so I'm just going to screen, and we're going to make this buttons, and we're going to make, how should we do this? Let me grab a controller. We're going to do some 16 by 16 pixel boxes for the D-pad. Some 8 by 8s for the red buttons, and then some 8 by 4s, or 8 by 2 pixels for the other buttons, for the gray or black buttons. So what we'll do is we'll need 4 buttons for the D-pad. So D-pad, buttons, and screen. I always put, for the postfix on these, the kind of structure we're building. In this case, it's a screen structure. And we're going to be making 4 of those. And then for the red buttons, screen. And see, we have to make some decisions here. Do we want to account for Pro controllers? Because the button layout is slightly different. On the front it has the 3 extra buttons, which all map to existing buttons. And so we can just use a standard controller visualization for the test. I mean, it'll still work. It'd be cool, though, to have maybe a toggle on the screen that just swaps out the graphic for a Pro controller and a standard controller, and then takes into account. And that's just user controlled. It doesn't detect a Pro controller, because I don't think you can detect a Pro controller, because at the end of the day, it's just mapping to existing buttons. I think, if you know, if you've read the documentation or something, dataset user, let me know. But I'm pretty sure you can't detect a Pro controller. For now, let's just do a standard controller. So we're going to do red buttons. Red buttons, screen. And we need 3 of those. And then screen, we need, let's see here, there's 12 on the D-pad, and then the pause and option. So we have 14 buttons there. We're gonna call these gray buttons, and I know they aren't always gray. Gray button screen, and we're gonna be consistent gray buttons, and we need 14 of those. Now we need to initialize those. So we're going to do a series of for loops here. So for I equals 0, I doesn't equal 4. We're going to do our first set of screens. I doesn't equal 4. There we go. Here, I'm going to reorient myself a bit so I can see my keyboard. Let me know if I need to adjust my audio. Okay. Yeah, there we go. I++. D-pad button screen. So we're going to be going through all 4 of these, equals new screen. And those are initialized. At least the structure is initialized. The buffers are not initialized yet, but we'll do that here in just a second. We're going to duplicate this 3 times. We're going to change this to 3, and then this to 14. And what I'm going to do to future-proof this a little bit, let me think about this for a second. Do I need to future-proof this? 4, 3, 14. This isn't really going to change. These values are always going to be the same, I believe. Yeah, let's leave them. Like the D-pad is definitely not going to change. There's only 4 directions there, so we should be fine. Okay, thanks dataset user. Yeah, so this is fine. Okay, so then in each one, oh, we need to change. We just need to replace these. So we're initializing the right structures for each loop. So we've allocated memory for those structures, and now we need to create a buffer for each one of them. So we can actually do that outside the loops. This is the problem with working with loops, because I only need to initialize a buffer for these to point at. I only need to initialize one of them. So what we can do is just tell it on the first one. So if I equals 0, this way we only run it once. Alloc simple screen. And I actually need to look up how to do this, because I've already forgotten. I always forget the parameters. Let's just do this. Let me just open up the source code here. Library. Include. I'm just going to open up all these, and then that way we can just come here to screen.h and search for alloc simple screen. Allocate says set. What's the difference? Initializes. Well, this is the one I'm used to. So we need to tell it what depth we want them to be, the width, the height, and the screen that we're actually, the screen structure we're allocating data to. Do we need to do that for all of them? I don't think we need to do that for all of them. Here, let's open up. I need to open up the C file now. Where are you? Source, there we go. Or vlib screen, and alloc is probably this one. Alloc simple screen. So it goes in here. Mallocs for the data. What is it setting here? It is setting all this. So maybe we do want to do this for each one. It's a little bit of a waste of memory, but we're not using a lot of memory either. So let's go ahead and just, so backtrack on this. We are going to do this for each one. So we're going to set the depth to, we're going to make them 8-bit, and we're going to just set them for now. What we're going to do is we're going to just lay them out on the screen. So I want it to do I times, oh wait, no, this is the width and the height. So for the D-pad we're doing 16 by 16 squares. And then D-pad button screen I. There we go. So right now those aren't any color, but we can set those colors. And I'm going to have to look this up too, because I think I've forgotten how to do this. We'll see. I think it's, let's see if we can figure it out. Mem set and destination, which is D-pad button screen I data. The data is just the pixel data that we're affecting. Oh, I think we might need another for loop. No. We just need to calculate how many bytes. We're going to set it to the palette ID we want it to look at, and then how much. And I think we can just go, because it's 8-bit, we can go 16 by 16. And that will paint that many bytes. The other thing we need to do for this to show up, well, let's finish this. Let's say we've painted it. Now we need to create, so we need to create a set of sprites for each one of these now too. So I'm going to go D-pad, buttons, sprite. And we need 4 of those. So down here we go, we point to our sprite. We're setting our sprite, button sprite I, and equals set, I think it's set sprite. Set sprite. Nope. Sprite. Create sprite. Sprite of screen. And we give it an X, Y position, and then the screen that we're doing. Jump back. Sprite. Sprite of screen. And then it's our XY position, so we're just going to give it I times 16 plus 2. We'll just give them a 2 pixel spacing between each block, and then we're just going to put it at 8 pixels down on the screen, and then screen, D-pad, button, screen, I, like that. Okay, and then we want to attach sprite to display at layer, D-pad, button, sprite, I, so sprite display at layer, let's go ahead and do 0. Just like that. And we should actually see something. So this is number 5. Let's just run a make command, make sure everything is, yeah, it looks like everything's fine. And 5. Oh, is our debug sprite still active? No, it isn't. So, okay, so our screen buffer is working. So why were they all black? We want to make them red, right? So what we did here with this memset command is we pointed at the data. All this data is, that's what the actual pixels look like. And because we're using depth 8, it's expecting a color lookup table. A color lookup table, all it is you have 256 IDs. And in each of those slots, there's a color assigned to those. And so what we're doing is we're assigning all the pixels to look at slot 3 of our lookup table inside of our data, our 16 by 16 pixels. And so we have to set this slot to a color. So let's go ahead and do that. I'm going to do that right here. Actually, I'm going to do it above the screens. And we can do that pretty easy. So in the TOM registers, where the color lookup table is stored, there is a color lookup table called color lookup table 1, and we want to look at slot 0x03, and we want to set it to, and I'm going to just set it to red, F8. And I actually learned a really cool way to set red. So you can just use hex values like this. This is, if you're, an elite programmer, you would use that. But I actually figured out an easier way to do it, and that's this right here. I'm just going to copy and paste it. So the way color works for the lookup table is it's a 16-bit value. And I'm going to write that out. So it's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. These are bits, so they're either a 0 or a 1. And this took me forever to find, and it's because I wasn't looking closely at the original Jaguar documentation, because I couldn't find, nobody mentions this online that I could find, at least at the time I learned this. But color on the Jag for low bit depth color is RBG, not RGB, which is what we're used to. So, and I don't know why they did that. I guess they wanted to put green down at the bottom because it actually uses more bits. So the way it's split up is it's 5, 5, 6. So 5 bits for red, 5 bits for blue, and 6 bits for green. And a lot of people who aren't familiar with this will probably ask, well, why are there 6 bits for green? Why wouldn't you keep it equal? And the reason why is because the human eye can actually perceive greens better than the other two colors. And so our computers take that into account. So we can actually split this up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6 for our green. So that's how it works. What's cool about this is we can kind of like sliders in a paint application. You have RGB, right? In this case, it's RBG. We can actually use decimal values, which is what I'm using here. So 4, 4, and 8. Those are the decimal values. And the reason, and I'm not going to go into detail with this, but 5 bits, you get 0 through 31. And same thing for blue, 0 through 31 in decimal. And then for 6 bits, you get 0 through 64, so it's doubled. So you have double the resolution in terms of grains there. And so what we can do is we can use a decimal value, and then we can bit shift that over. And so basically what I'm doing is I'm saying, oh, I'm doing 4, which is 0, 1, 2, or 3, 4. So I'm taking this value and I'm shifting it 11 bits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That didn't work. 1, 2, 3, 4, 5, 6. That's right. Oh, I didn't take into account the space. 1, 2, 3, 4, 5. And we're moving it down here, and then this is set to 0. Okay, we did that. And then on this one, we did 4 again, and we're shifting it 6 bits. So 0, 1, 2, 3, 4, 5, 6. So right here, it's adding 4. And then on the green, we don't need to shift any bits. And so it's just, and I actually don't know what that is. And I'm going to pull up a calculator really quick so I'm not wasting time. All clear, decimal, 8, binary. So in binary, that's this. And let me write this out really quick. 1, 1, 1, 2, 3, 1, 1, 1, 2, 1, 1, 2, 3, 4. That gives us a hexadecimal value of 0x. 0x 3190. 3190. And so if you don't want to worry about the hexadecimal, you can actually just do this. So if you know that your red, your blue, and your green values are 0 through 31, and for green 0 through 63, you can just use decimal values and just bit shift them to the right place, and it automatically creates this value for you. So anyways, maybe that was clear. Maybe that was poorly explained. I don't know. But once you realize that it's just between a 0 and 31 value and a 0 and 63 value, you can just use bit shifts and you don't have to worry about hexadecimal anymore. And if you're familiar with sliders or even hex values, RGB hex values for 24-bit color, it makes sense to do it this way. It's a bit simpler to work with because for example, in a painting application like Photoshop or GIMP, it's a 0 through 127 or 128 values or something like that. And so we're doing exactly the same thing, but down here. Anyways, it'd be cool to write a little program, and maybe I'll do this one day on the stream, that will just automatically convert a 24-bit hex value to a 556 hex value for me, so I don't even need to do this anymore. Of course, this is super efficient. It's not as efficient as just putting in the hex value, but it is efficient doing it this way. Anyways, we're going to make this red. So I'm just going to do 31. We're going to max out the red, and no blue, no green. And that should make, yeah, so our boxes are now red, which is cool. And while we're at it, we're going to set our color lookup table for position 4 for our gray buttons. And I actually had, this is actually a gray right here. but we're going to do a brighter gray. I'm actually going to do a 50% gray on this, so which is actually 15, 15, or yeah, 15, 15, and then this is 31. We can actually check that here really quick by switching it so it's painting ID 4. There it is. That's what our gray buttons will look like. Okay, we have our, why didn't that put a space? Let's see here. I times 16 plus 2. This should have spaced them out. Don't know why it didn't. Huh. That is weird. Oh, whoops. We need to do I times 2 plus 16. Pretty sure. Order of operations. Pretty important. Oh no, that made it worse. Come on, Will. This is simple math. You've done this before. Let's see here. We want it to at least space out the width of each one. Right? And then for, right? Do I need to just do this? I times 2, something like that. There we go. Got them. Okay, those are spaced out. Okay. Now we just need to repeat this for our other 3 sets, or other 2 sets of structs, and just swap out the names. And change how, oh no, we don't need to change any values except for maybe this. We'll put this at 32. These are our red buttons, right? Oh, you know what we'll do for the D-pad? We're going to make those blue right now. So this will be red. ID 4 will be red. 0, 0, and then this will be blue. So we'll do a 31, 0, and 0. And then our gray buttons will be here. I should have just duplicated that. This will be 15, 15, 31. And we need to switch this to 4. We bump those down. Our red buttons are going to be 8 by 8. There's only 3 of those, and we need to create a set of sprite structs to work with. A red buttons sprite, like that. And let's do that for our gray buttons as well while we're here. Sprite. There we go. Got all those. Now we just need to swap our instances of those out. Red buttons, screen, 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 and then red button sprite. Swap those out. There we go. That should give us our, this isn't right. This needs to be 8 by 8 and 8 there. They are shifted down. We're coloring them with ID 4 instead of 3. Should be good. That should give us, oh, missed something. Warning, error, gray button screen undeclared. Gray buttons screen. It is declared right there. 586. Gray buttons screen. Must be another error. Case label 619. Oh, I must be missing a... there's our problem. Extra curly braces. There we go. There we go. So our D-pad up on top and our red buttons down below. Got those. Now we just do the same thing for our gray buttons. We might need to be a little more tricky with these. With their positions anyways. Okay, let's swap out our structures first. And our sprites, like that. And these are going to be shorter. Let's do half size to begin with. They're going to be painted with ID 5, and we need to just change how much it paints to match the width and height of our sprite buffer, of our screen buffer. And this is fine here. We do need to bump this down to like 48. That should do it. There they are. There's all of our gray buttons. So we do need to decide which buttons are which. What I'm going to do is for the D-pad buttons is it's going to be top going clockwise. So 0, and we won't type all this out, is D-pad up. 1 is D-pad right. I'm just going to do a few of these so the audience gets an idea of what's going on. So, which might just be dataset user right now. Thanks again for watching or listening, whatever you're doing right now. Down, and 3 is D-pad left. And again, if you aren't familiar with programming, we count from 0, not 1, even though when we're declaring an array, we are counting from 1. So this is one of the few instances. So when you declare an array in C, you're counting from 1. But when you reference them, so when you say, oh, I want to affect the first one, you start with 0 instead of 1. It can be a little bit confusing at first, but you get used to it pretty quick. And then for the red buttons, 0 will be A, 1 will be B, and 2 will be C, like that. Now for the gray buttons, what I'm going to do, just so I can keep it straight, cheers, I'm not a coder, only used to play around with BASIC, but I still find this pretty interesting. You know, the only BASIC I've ever done is what I've seen in YouTube videos. So whenever, like for example, LGR, he always does something scatologic. He says print poo go to 10 or whatever it is. So it just loops the same thing over and over again. Anyways, that's about all I've done in BASIC. I think I've done a little bit more than that over the years. Like we used to have an Atari 800, and so I'm sure at one point I dived into the manual and tried some things out, but there was no way that 7-year-old me was gonna figure any of that out without help, which I did not have. I had plenty of brothers, but none patient enough to sit down with a 7-year-old, which I don't blame them. It's difficult to do that and teach them how to do BASIC. Okay. So what I'm going to do is, for the gray buttons, we're not going to type this all out, but I just wanted to define that 0 is pause, and 1 is option, and then, from then on, so 2 through 13, which is the next 12 buttons, is the D-pad, or the number pad, and that's just going 0. Now, how do we, actually, 2 through 11 is a number pad, with 12 being star, and 13 being pound, the pound sign. And I know if you're over in the UK, you may not like me using pound, but okay, we'll use hash. Hashtag. We'll use hashtag. There's always a fight when I'm doing the manuals for Albert at Atari Age and Reboot. Because me and Albert are fine with pound, but Reboot, he's over in Australia, I believe, and he's like, no pound. We can say number sign or hashtag, and I think what we do is we end up saying number sign, but I'm fine with hashtag. Anyways, so yeah, so 2 through 11 is the number pad, and 12 is, I put start, not star. Star, we could say asterisk as well, but we're gonna just use star. Okay, so that's defined. We need to define that because as we start making things pop on and off, yeah, that's going to be pretty important. And the other thing here is, how are we going to make these highlight? That's a really good question. So what we're going to do to make them highlight is we're actually just going to use a mem set to paint them. I'm a little worried that might be too slow, but these are pretty small, so it may not be a big deal. What we could do is create another set of buffers that are painted a different color, and then we just change what they're pointed to, the data. So right here, this data is, oh man, maybe that's what we do. Oh, let me think. Nah, I kind of want to just make a separate buffer that I can point it to. We only have to do 3 new buffers for each one. So let's do that down here. Highlights. And we're going to create a set. I need to change some values here. So our completely red isn't going to be completely red anymore. It's only going to be half red. And our gray, I'm only going to, no, that's actually fine. We're going to leave our gray the way it is. And we're going to only do, make our red half as bright. There we go. And then we're going to create some new buffers. And these are going to be, actually we're going to go see. We're going to see what they're going to be. I opened that up, didn't I? Yeah, I did. Data, we actually need to see what that data buffer is, what type it is. Depth D. He should have the buffer here somewhere. Where are you? Depth. Phrase. It's phrase data. So what we need to do is just create a phrase buffer floating out in space. Phrase. And we're going to call this D-pad buttons highlight. I guess I could just do another screen. Maybe that's what I should do. Let's just do that. D-pad buttons highlight. Yeah, we're just going to create another screen. That's fine. No, I don't want to do that. We don't need to do that. Highlight. This is fine. Equals, and then I can just malloc the data. And size of uint, an unsigned 8-bit integer, times by 16 times 16. Just like that. That should give us what we need. For that, we're going to do this for the other 2 types of buttons that we have. So this is red buttons highlight. Make sure I spell that. And these are 8x8. 8x8. We're going to mem set these in just a second. And gray buttons highlight. Yep, just like that. We're going to have to devise a way to test this really quick too. We'll do that here in just a second. So we're going to mem set these as we do them. I'm just going to copy this, save us a little bit of time. We're doing pretty good on time, actually. We're probably only going to get to testing one controller, maybe two. We'll see. But what I'm going to do is after the color lookup table ID 5 here, we're going to set 3 more for our highlights. So I'm going to mark these as lowlights and these as highlights, like that. Okay, and this is going to be 6, 7, and 8. And so we want our blues to be a brighter blue. So I'm going to just set this to 63. And then we want our reds to be a brighter red, which is 31. And we want our gray to be a brighter gray. And so in this case, I'm going to do another 8, which gives us 23. 23, and this another 16, which gives us 47. Remember, our green is double the resolution, and so we just have to make sure we just, for gray, we just times it by 2, whatever we change the red and blue values by. Okay, so got those set. Let's do this one now. That's 6, this is 7, and it's for an 8x8. 8x8. This needs to be an 8x4 for the gray buttons, and we need to mem set those to. We can actually I know a really easy or a fairly easy way we can test this out for. Okay, so we have our highlights supposedly made, the buffers for those, and all we need to do, and I can actually test that by, well, before we do that, let's run a make command, make sure no syntax errors, good. Let's take a look at what it looks like now, just so, uh-oh, something broke. What broke? Ah, something's crashing. Didn't like what I did. Okay, there's definitely something breaking there. Oh, whoops. I didn't swap these out. It was trying to paint in something that didn't have memory. You see right here? This was the mistake. D-pad button screen. I needed to swap it out for this because that's what we're changing the values of. And same case for this. And same case for this. Got it. Uh-oh. And yeah, that's right. It doesn't have a member. Oh, whoops. It's not a structure, it's just a type. So we can paint directly to it. There we go. Okay, we won't see anything yet. I wanted to show what it looks like now. So when I add this extra code, these blues should be brighter, these reds should be brighter, and these grays should be brighter. And we can do that right here. And we'll just do it with the blue buttons first. All we need to do is take our D-pad button screen and then the member data and set it to our D buttons highlight. And I already screwed up because we need to tell it which structure to do that. And we're going to do it to all 4 of them. So now we should have a brighter blue. And we don't. So I don't know what's going on. D buttons highlight. 6. It is definitely a brighter blue. This should be working. D button screen. Data. Yeah, it's just a pointer. This should be working. Phrase. Mem set. We're going to this one right here. That's a 16 by 16. That's correct. Just wondering if we actually, maybe we actually didn't. I don't think we need to set the address. Let's see if there's any errors. There's no errors. I don't think this is going to work either. Yeah, that's definitely not going to work. Huh. Well, maybe for time's sake we may do this another way. There's actually a couple different ways I could do this highlight thing. This should be working though. Is there any reason why it wouldn't be working? Doesn't need that screen structure. I don't think it does. I don't think it needs any of these. Because it's a matching type, it's a phrase pointer, we should be able to just set it. Which is what I'm doing. Phrase pointer. That's correct. We're allocating it. We're painting some data. Here, let's not do this really quick. Let's see what happens. I expect it to look like garbage, but I don't see it doing anything. It shouldn't matter that we're doing it after we attach the sprite, but oh, it does matter. That's strange. That should not matter. Huh. Because now it should be highlighted if we uncomment that. Oh no, it's still not working. Well, here, I'm going to change the color a little bit here. We're going to set this to 31. So it gives us more of a cyan. Okay, it is working. That blue just wasn't very bright, I guess. My blues? 31. Huh. Strange. So it is working now. What I don't understand is why it wouldn't update after we attach a sprite. Because when we're just pointing... Oh! Because we shouldn't be setting that. We should be setting... No, that's fine. That's fine. This should actually be the sprite. So if we go to the sprite structure, let's just double check this in the documentation. If we go look at the sprite structure under sprite.h, there should be, look at that, there's a phrase of data. So what it's, oh, that is interesting. No, because it's just pointing to that same buffer under the screen. Pretty sure. So if we go to, we need to open up a C file here. Screen set simple screen. Nope, that's not the one. Let's set screen to sprite. There we go. So here's our sprite structure. We need to find where it sets the data. Right? No, that's animation data. Right here. Yeah, it's just pointing to the screen data. So if I change the screen data, what the screen data is pointing to, it should update the sprite data as well, but it wasn't doing that. Huh. That is a bit confusing. Because if I do this, this should work. And to show as an example, let's just do the first blue square as an example so we can see it working. So that's what it's going to look like highlighted. But I should be able to do this with the screen as well. It should be no different. Right? Yeah. Should be no different. There's something I'm missing there. Anyways, we have a solution. That's fine. So we need to set the sprite, not the screen. I just need to remember that. Okay, so we have our highlights. We can actually start testing now. The way we do that is we just set up a bunch of... Oh, so we have a problem here. We need to change this. So right now, universally, you hit Option, and it sends you back to the main menu. But we need to change that for our controller test. How do we get out of the controller test? When we're testing the controller. Maybe we make it a 3-button combo. Let's do this. Let's do... I'm going to wrap these in parentheses. And we're going to wrap this in a set of parentheses because we want it to do the check before we check the controller delay. So I'm going to copy this. And we're going to do 3 buttons. So, and that, and that. So we're going to do 3 buttons. We're going to do, star. And I always forget what he calls the, I think it's hashed. No, it might just be pound. I can't remember. Where is that? Joypad. Star, right, sharp. Oh yeah, that's right, sharp in musical notation. That's another way to say it. I don't know why that symbol has so many names, but it does. Star, most people don't know it as sharp. That's why that isn't as commonly known. I know it because I know how to read musical notation. I'm no good at it, but I can read it. But yeah, so sharp, and let's do the C button. So that'll be our button combo to break. We can test that out right now. 5, so star, sharp, and C. There we go, we're back out. And you'll see that our sprites are still on screen. So we need to write some code to make sure that we unload all of our graphics appropriately. Let's go and do that right now. So we need to unload all of our sprites for each one of these and all of our screens for each one of these. And yeah, sprite screens, and then these phrases here. So the first thing we have to do is we have to detach the sprites from the screen. And I'm going to create these, copy these for loops because we're taking away the same things that we added. Unload sprites. So what we need to do is detach our sprites. So detach sprite from display. We don't need these extra parameters, so those are detached. And then we need to free our sprites. Free. Copy this over like that. And then with screens, it's a bit trickier. He doesn't have, as far as I know, let's go check. He doesn't have an easy function for unloading screens. And this plagued me for a long time. Just clear. See, he has these clear screens, but those aren't actually unallocating the data in memory. That's not what these do. These just set the memory to 0. Screen copy, put pixel, put pixels, H horizontal line, vertical line, line, screen rotate. Okay, so he doesn't have any helper functions for that, and yeah, this plagued me for a long time. I was getting crashes all the time, but once I learned a little bit more about memory allocation, I was able to figure it out eventually. So there's something we have to do, is we have to free the data member first, and then we can free the sprite structure. So we go free D-pad button screen I, and then the data member, because that is it. When we run this alloc simple screen, what that does is it does an allocation of that phrase data member. It allocates memory specifically for this, not for the structure of D-pad button screen. And that's why we need 2 separate commands for that. So we just copy that and just get rid of this, and that's gone. Easy as that. We can get rid of the rest of these. We don't need those. Oh, we need the detach sprite. Just like that. We can copy these red buttons, red button sprite and screen. Red button sprite and red button screen. Like that. This is gray button sprite and gray button screen. Copy. Paste. Okay. I think we got those, and then we need to get rid of our last 4 phrases. Phrase types. So these 4 we need to free those up. So that's D-pad buttons highlight, red buttons highlight, and gray buttons highlight. We can do that right here. So D-pad buttons highlight, and free red buttons highlight and gray buttons highlight, just like that. And we're set. So now, if we build and run our program under 5, and then we back out with *C, like that, it should be all gone. And we can do that over and over again without any crashes. You'll see that there's a little bit of garbage as we remove those. And what we can do, there's 2 ways we can fix that. We can run a vertical sync after the detach each time we do a detach. Actually, I'm not going to worry about that right now. I can clean that up, make that look pretty later. Not worried. Okay, let's do our testing. So, do I need to worry about that? Not right now. We're just going to do first joypad. Oh, this is going to get messy really quick, especially if we're doing 8 joypads. So I'm pretty sure the removers library has support for 8 joypads. Let's see if there's a reference to that in the documentation somewhere. Look at that. Joypad states. And we have access to J1. 1. Why don't we have access to Joy2? Uh-oh. Am I missing something? Oh, there it is. Oh, I see. It's combining them. So if you have a team tap, it'll be joys 1, 3, 4, and 5, and if you have a team tap on port 2, it's pads 2, 6, 7, and 8. Okay. Yeah, we figured that out. That's good to know before we jumped into this. So we can test all eight of them here. What I'm interested in trying to figure out right now is how to consolidate my code so we aren't duplicating code for all 3 or all 8 joypads. And what we'll need to do is create a function that just brings in this unsigned long value. And we run that same function 8 times. That way we don't have to type out the code for every button 8 times. We only have to type that out once, and then we just use one line for the function that points to that code that we would be duplicating 8 times rather than, yeah. Anyways, hopefully that'll make sense here. So we're going to create a function down here, and we're going to call it controller check. And we may change these names later on. And it's just going to be a void function. We're not going to be returning anything. But we will need to be passing in some things. We're going to be, actually, what we'll probably do is we'll just make these global. In fact, we're just going to assume that they're global, and we'll go and do that when we get there. We're going to have to make our screens and sprites for our buttons, visualizations of our buttons, global variables, so I don't have to pass them into the function directly. I don't know if that's bad practice. It probably is, but for a program this simple, I'm not too concerned about that. And then we just need to go through and check every button. We're going to start with the D-pad. In fact, how am I doing that? So you'll see here, yeah. So this is what I'm looking for. So what we're going to be doing is passing in this JState into the function. And we saw what type of value that is right here. It's an unsigned long value. And I'm just going to call it J, because it won't matter what number it is until we pass the function. But inside the function, it's only going to be testing each controller, or just one controller at a time. So unsigned long J. That's what we're going to be passing in. And checking against. So if our controller J is joypad up, like that, yeah. You can tell that I didn't think through this before the stream. So what I'm thinking of right now, I'm going to speak out loud, is so when we press the button, it's going to highlight. But we also need to check for when the button is not pressed. And so what we can do is we can just do an if-else statement. I'm trying to make this as efficient as possible because I don't want it to keep setting something if it's already set. So if it's up, I do want it to be set. I'm just wondering if there's a check I can do, and this is D-pad buttons sprite data does not equal D-pad highlight. Yeah, that should work. I'm going to put these in parentheses just to be safe. No, that one's fine. I always get worried about these. Oh, that should be fine. And then we just set it. And sprite 0 is up. We set it to equals D-pad buttons highlight, just like that. We're gonna test this right now. So we need to declare our function in our header file right here. That's all we need to do there. It's called control check. We just need one L on that. One L. So I would copy that. We're going to put that in our while loop. Like that. And this is J state 1, J1, like that. And we're going to be repeating this 8 times. And so, but we don't want to do that quite yet. What we're going to do here is actually move these to our header files, so now they're global. I am going to do controller check. And I'm just going to do that. Pump it down. Okay, those are good. And then I need to make these global as well. So I'm going to copy this. We're obviously not going to keep it all, because we just want to declare them, not do any definitions. We're just gonna delete that, delete that, delete that, delete that, delete that, and delete that. There we go. There's our highlights. Okay, so, and then we need to adjust these so it isn't redeclaring them. We're just setting them in code. We are defining them. That's the word that's used in C. Let's run a make command, make sure everything's square. Looks like it is. And so up should work. Yep, there it is. So it sets itself, but it doesn't unset itself when it's not working. So, and this is where it's actually, no, this isn't difficult. This should work pretty easily. We just need to do an else if. So when it's not being pressed, and it hasn't been set back to D-pad button screen 0 data, then we set it back to that. We can just copy this again, get rid of this extra thing, and set it like that. So it only does it once. What I was kind of, that long pause I had a few minutes ago was just thinking through, I don't want this to continuously set because that will slow things down. And so what we're doing is we're checking to see if it's been set already, and if it hasn't, then we set it. And because it's been set, this won't be true anymore, and so it won't do it again. So, let's see if that works. Up. Oh, yep, there we go. Now it's flashing. So this is also why I paused. And I've figured this out twice before, but I've forgotten how to do it already again. And so I'm debating whether I want to spend the time on stream trying to figure it out again. What I could do is open up the code for Crescent Memories and just figure out how I did it there. But maybe we'll try to do it here really quick. So under joypad, and it looks like it's not here. Oh, actually it is here. So he is using 24 bits to check, and he sets them to 1, or to he sets the position to 1, and so we can use this to check to see if it's still being pressed. So in our else if statement, we want to see if it's 0. And if it's 0, then we do. If it's not, then we want to skip it. I'm just wondering if we're going to have to redo our logic here completely. So we have 24 bits, right? And you guys can't see this right now. Maybe I'll add this really quick. Let me just a second. Studio mode. I'm going to add a window calculator. Like that. KCalc. There it is. Okay. And I'll try to make this big so you guys can see it. Okay, so we have Lee. Good to see you. Passing visit at work. Just saying hi. I will watch later. Thanks for watching. Thanks for stopping by and saying hi too. Good to see you. Okay, now we have a calculator. So this calculator is really nice because it shows you binary, octal, or yeah, octal, I think that's how you say it, decimal, and hexadecimal. So we can actually type this out. So our first bit is 1. But we want to, let's see here, we want to mask out all the other bits because we don't want to check those. We just want to check the single bit. Let me see if I can type this out and then I'll explain it, because I don't completely understand it myself right now. Sometimes I have to just type it out. So we want to check for just that, for 24 bits. How do we do that? How many? Let's see here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There's 24 bits, right? 4, 8, 12. Oh no, that isn't 24 bits. 1, 2, 3, 4. That's 24 bits. 3, 4, 5, 6. No, it isn't. Come on, Will. Basic math. 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There we go. That should be 24 bits. But we want that last bit to be a 0. We want to mask out only that one. So what we can do is take J, which is our unsigned long value, and mask out that one bit. And I should have paid attention to that. I'm going to need, sorry, I'm also wrangling. There you are. Okay. And I want to be able to take the calculator out right there. Okay, I can take that out. So we need this hex value, which is 6Fs. But we just need that many positions. So 0x, why isn't that working? 0x, and it's 1, 2, 3, 4, 5, 6, and we're masking out the first bit, which would be 1 in this case. Because that's what we're checking. So, and I'm going to have to do double parentheses on this. Because once we get that value, we need to say, is it only if it's equal, or let's do this, if it's not equal to 1, and then we'll run it, because we know from our header file here, joypad, that we're setting 1 when up is pressed. Yes, I'm hoping that this isn't reversed. My memory is kind of telling me, oh, it's actually backwards from what you think. But yeah, it does the check against J. It masks that bit. Oh, this is the same thing as just using this. Hi, Ruth. I am doing some pretty I think, pretty dry stuff, but it can be interesting too. What I'm doing is I'm building a set of tools to do audio, video, and hardware checks on the Atari Jaguar. So I'll show you here in a second once we test this. I think I can just use this here. Does not equal... I think I can just do that again. Yeah, I think this will work. 5. Yeah, there we go. It's working. That worked just fine. Okay, let's see if I can explain this really quick, and then I'll show you around, Ruth. So what we've done here is we've masked a bit. Can I show that on the calculator? Let me take a look here. So you can see my cursor, right? So masking a bit, all we're doing is we're using, in fact, I can do it right here. This AND operator, what we can do is if there's a 1 and a 1, then you keep that value, but then the rest you set to 0. So if we do 24 bits again, so if I do AND 1, 2, oh, it's not going to do anything unless I add a 1. 1, so we want to mask just the first bit, equals, it should just keep the, yeah, and this calculator isn't going to show us. So let me write that out again. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, I'm missing 1. There we go. So we know up, if this is set to 1, this bit is set to 1, that means we know we're pressing up on the controller. So what I did is I used joypad up, which is just that 1, to say, okay, we're going to mask that, and then if it's still joypad up, or 1, then we know it's being pressed. And so in our if statement, if it's not being pressed, we only want to go to here if it's not being pressed. Then that's when it sets it back to our non-highlight color. Anyways. Okay, yeah, in fact, if Lee's still on too, he may want to see this as well. Let me turn off the calculator. So what I'm doing is just a set of audio visual tests for the Jag. So the first one is your position, the display position. And what this does is it universally changes anything that's added to the display, changes its X and Y position. This allows, and these magenta bars are also really useful to see if your CRT, if the image is skewed a little bit, so you can fix those things. Anyway, so there's that test. And then color bars, obviously used for color calibration, so setting the colors on your screen. And then a white screen. According to the guy in the forums, this is used to test power. And my guess is this wouldn't be absolute bright if the power is fluctuating a little bit. Something I'm not entirely familiar with that process, so I'm not 100% sure. And then the sound balance test just tests the speakers, the sound output of your console, and the speakers on whatever screen you're using. So let me go turn the audio up on this so you can hear it. So right now, jump back, it's balanced, but we can pan it to the left. And you may not be able to hear this without headphones, and then you can pan it to the right. And then I have some shortcuts for left, center, and then right. So it's just for balancing audio. And right now, what we're working on is this controller test. And so we're just creating something that shows that all of your buttons are working, basically. So, and there is a keyboard shortcut that I need to remember to get out of that. In fact, we may change that not available text to the keyboard shortcut to exit. And right now there's nothing in screensavers either. So anyways, and I got this cool fade effect. It's a live fade, and so I'm just changing a global variable. That just means a variable that can be read from anywhere inside the program. When I change that value, I have these functions that are fading things, and so if that value changes, it automatically fades to that color. So it's kind of cool. And then I just have a lookup table of different colors, and then it's cycling through those every couple seconds. So anyways, that's what we're working on. Cool. I'm going to turn that volume back down in case we do go back. Okay. Well, thanks for joining us, dataset user. Thank you. You have a great day too. You implied that you're somewhere else on the planet, so if it's evening, have a good night's sleep. If not, have a good rest of your day. Thanks for joining us. Okay. Where were we? Okay, so we did D-pad up. What we're going to do now is we're going to go ahead and just go through and do the rest of the buttons. And so this is going to be a little bit dry. I'll try to make it interesting as we do it. So down. And I'm going to do that here and here. And we need to change all these values to 1. Because, or no, sorry, I already screwed up. This is right. This may be more interesting than I thought. Because if I keep making mistakes like this, could be one of those, you're pulling your hair out going, no, you messed up. Why did you miss it? It's funny, I watch other programmers on other streams every once in a while when I'm learning something. And they'll make what seem like obvious mistakes, and that's because they're a little bit nervous. They're on stream and they're trying to be quick too, and I'm trying to be quick, and when you try to be quick, things go wrong. So this should make right work. Yep, there's right, just like that. So yeah, I think we have a working... Oh, let's test up and right at the same time. Look at that, there they are. It's working great. Working great. What time is it? 8:24. Oh yeah, we're doing great. We're going to be able to finish at least one controller here. Hopefully we'll be able to test it for 2 controllers. And we actually have it set up to test for 2 controllers, which is awesome. So right now, this is down. We're going down now. So our buttons are set up right now as 0, 1, 2, 3, 4. And starting at 0 is up, and then you go clockwise. So 0 is up, 1 is right, 2 is down, and 3 is left. Oh, I think I got that right. Two, 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 two. Okay, thanks, Ruth. Love you. We'll see you later. Thanks for stopping by. Oh. For anybody else on the stream, that's my oldest sister. So I'm glad she stops by. We have quite an age difference. We're I think 15 years, something like that. So she's the big sister of the family. Okay, let's. Oh, I did not. We did right down. This needs to be left. Left. And here's the thing. This seems like a lot of repetition, but we'll only have to do this once for all 8 controllers. So it's not as much as you think. It's just doing the initial set will take a little bit of time because there's... How many buttons are we dealing with? 14 plus 3 plus 4, which is 21 buttons on a standard controller. And it's technically the same amount of buttons on a Pro controller too, at the software level anyways. Let's test our D-pad. They should all be working now. There they all are. In fact... Oh. So, we have a problem. We have no way of showing other controllers. Not easily, anyways. The other issue we have, let's see here, if we do I'm glad we just counted. 8 times 21 is 168. Okay, so we're fine on sprites. For each display layer, you can only have 256 sprites. So we're not even coming close to that. So we're fine on that. You know what we could do? We could actually repeat this pattern all the way down. Let's see here. 1, 2, 3. We could fit 4. Man, we can almost fit all 8 controllers on screen. If I made these 8 by 8, we could do 8 sets of these buttons and do all 8 controllers. Wouldn't that be awesome? How do we do that? I'm thinking, give me just a second. So if we change the layout to make it actually look like a controller, we can consolidate space quite a bit. It's just figuring out all the math to automate the layout of that, which might take up a lot of time. Here's the thing. I've kind of accomplished what I wanted to do with the stream, so maybe I will just spend some time making this look pretty and then think through how many of these we're going to need. So in fact, we're going to swap out some values here. We're gonna create this, make this a little more procedural. So we're gonna create a global definition for how many D-pad buttons we have, which will end up being 4 times 8 for 8 controllers, right? So we're gonna just go D-pad buttons total, like that. And I capitalize this because it's just a habit, because I've seen other programmers do this. We're going to create a define or a definition for that, which is 4 times 8. Because we're going to need 4 sets, or 8 sets of 4 buttons that represent the D-pad for each controller. Oh, this is really going to be tricky. We have to do a multi-dimensional array. So maybe what we'll do is we'll initialize everything, and then we'll do another set of for loops that lays everything out on the screen correctly. Yeah, I think that's what we're going to do. We do need to change this though. And then wherever there's a 4, which I already swapped out here, but we need to swap it out here as well. We need to make sure that that's there. And then red buttons. So red buttons total. Like that. And right here. And this is going to be a little bit of a mess to begin with, but we'll get everything worked out. Is 3 times 8 controllers. In fact, we can go define controllers total like that, so I don't have to type 8 each time. I do need to do that though, I believe, in order for it to work properly. Controllers total is 8. Okay. And while we're here, let's do our third one. Gray buttons total, which is, what was that, 14? And we need to change that here. And right, oh, down here. There we go. Okay. So right now, if we look at that, which it should, if I typed everything out correctly, did I save? I didn't save my header file, make, okay, we're good. 5, oh, it crashed, didn't like something. Didn't Here, let's do this. Let's switch this to different layers, just in case if it is having a hard time with that. Why is it struggling with that? Let's make this an 8x8. Like that. Like that. Yeah, that's fine. Let's see if it can do that. Oh, something's crashing it. Let's try doing just... It's good that we... Hi, JQ. Good to see you. Okay, that's working. Did it not like the red buttons? No, it's fine with the red buttons. Did it not like the gray buttons? It may not like the gray buttons. How many? So 8 times 14. It's doing 112 of those. Why would it be struggling with that? Oh, it's probably because it's drawing it too far off screen. Okay, so what we're going to do is we have to lay these out appropriately. And what we're going to do is every, on the Y, it's going to be 48 plus, and we got to do some math here. So every 14 buttons, or, yeah, 14 divided by I. Divided by I. Yep. And what this will do is it'll just draw those gray buttons. Every 14 buttons, it'll go down a line and draw them. Let's see here, 48 plus I times, let's see here. Yeah, I will just give it a times. I'm just working this out in my head. Bear with me. That should let it skip. Because I think what it's doing is it's... Oh no, it's still struggling with that. Let's get rid of these really quick. Oh man. Wonder why it's having a hard time with that. Let's do this. Let's drop the amount to just make sure it isn't some other problem. Let's do 5. That'll give us 40. Oh no, there's something wrong. Let's just try doing 1, which is 8. Yeah, there's definitely something wrong. What is wrong here? 8 times 4, that's correct. 8, 4. This is a little bizarre. 14. This should just be working. Gray buttons, highlight, not worried about that. Gray buttons, screen. Button screen, there has to be a typo here somewhere. Let's set this back to 48. Gray button sprite. Gray button sprite. That's correct. We are pointing to individual items in the array. There we go, that's working. Did it not like this? Oh, I'm dividing by 0. That's a problem. Not good. That's why it was crashing. So we need to reverse this. Yeah, it's just I divided by 14. I just had that backwards. Pretty sure that's why it was crashing. There we go. That's working. And I think it actually needs to be... Let me do the math here. So when it's 0, 0, 0, 0, 0, yeah, that's fine. Why is it doing it for every... Oh, because this is changing here. Here, let's do this. This should make it not change at all. Yeah, that's fine. But now, when we come here and do our big set, so 14 times controller's total, it should bounce down. Oh, man. 5. There we go. That worked. Why did it stop? In fact, it crashed. Why did it? Gray buttons total. Ah, that's why. I forgot to swap these out. There we go. We had 2 bugs there for some reason. Sorry if you can hear that upstairs. Somebody's moving a chair. 5. Huh. Oh, I forgot to save. There we go. This should work now. Okay, so it is working. I need to reset my X, though, every 14 buttons. See if we can figure out the math for that really quick. So, I think this should be I modulo 14 times 8. Same thing for over here. There we go. That's working. Now I just got to figure out a Y offset. Times 4. Times 4. This should just give us a solid block of gray with vertical lines, yeah. So, okay, cool. Got that kind of figured out. We're definitely making them all, which is a good sign. Excuse me, gotta stretch. Still waking up. We may not finish this today, but we'll see if we can get at least one controller laid out. Let's uncomment these other 2 for loops and make sure that's all working. There it is. Everything's there. For 8 controllers. This needs to be 8. Cool. So what I want to do is actually lay our buttons out. And we need to do this in a for loop. In one for loop for 8 controllers. So we're going to need some extra variables to work with. So I'm going to scroll up here. We're going to do I, and I. So we have a depth of 3 in our for loops. Lay out controllers. Let's see here. Int offset It's 2 values. So we're going to do a global offset. This is basically a point that everything's parented to, that we determine where from this point everything else is determined. And we're just going to make this 16 by 16, 16. So at pixels 16, x16 and y16, that's where we're going to offset everything. And we're going to do our first loop, I equals 0, I does not equal controllers total, whatever that is, which is 8 in this case. We could be using numbers, but I like to be as verbose as possible, so if I ever need to come back and debug this, it's a little bit easier to read. So for that, and then for each set of controllers, so we're going to go through each controller. So we hit our first controller, we want to lay out the D-pad first. D-pad. And we're going to be doing another for loop, I equals 0, and we're going to be going through 4 values on that. I does not equal 4. There's 4 on the D-pad. We can't use our define because that represents the total amount of D-pad buttons. And so we do have to use a number here or make another define. We could do that too. We won't worry about that right now. I want to see if we can at least get the D-pad laid out here really quick. So we need to lay the buttons in a cross pattern, just like on the D-pad. And this is going to be tricky. I've never done this before. So our first one, you know what we could do? We could just manually set this out or lay this out. So D-pad buttons sprite, and we need, first of all, we need our controller offset, and we can get this from this I value because that's what this outside for loop is for, is to tell us which controller we're manipulating the buttons with, laying out buttons for. And so we can do I. That gives us our offset times every 4 buttons, so times 4. So when it hits 0, it'll be 0 times 4, so it'll be 0, 1, 2, 3, and then when it's the second controller, it will be 4, 5, 6, 7 for the second, and so on. Let's see, or am I doing it? Okay, there's our offset, and then plus II. And that will give us, so it'll find our first controller, so if it's the second controller, it will start at ID 4, and then plus II, so 4, 5, 6, or 7. So when this goes 0, 1, 2, 3, it will go plus 0, 1, 2, 3, which will give us our offset. So this is essentially a 2-dimensional array, but done with a one-dimensional array. This is important to learn when you're doing lists of things, to learn how to do 2-dimensional arrays this way. So it can be pretty confusing at first. So hopefully I explained it clear enough. Okay. Sprite, and then we want to, in fact, let's do this. Let's create int D-pad button ID equals, and we only have to run this once rather than multiple times for each time we want it. And so we're just running this math, so it's stored in this variable, so we only have to do that math once, and it makes this easier to type out as well. So what we can do, we could just do some if statements and hard code the layout for this. I would like to do this procedurally though. So we want to get evens or odds. So if I so it can be divided by an even number. So let's do our evens first. So 0, 0 and 2. If I divided by 4, oh no, that doesn't work with 0, does it? How do you do this? I've done this before. Figuring out evens and odds. Oh. Let's see here. Let's do odds. Because our evens, so 0 and 2, are going to be up and down, and our odds are going to be 1 and 3. So let's do our odds. So if we modulo by 4, when it's a 0, we don't have a remainder. When it's 1, it will have a remainder of 1. And so if it's greater than 0, that's how we test. So I'm just going to wrap this in parentheses just to make sure everything. So odd values. Yes, yeah, that's right. Odd values. And now we need to lay those out. So it's x. Okay, how do we want to figure out its x? Is going to be I think I'm still not doing this right. Yeah, I'm gonna have to think through this. We're gonna have to just test it and see if it works. So for our left and right buttons, our left button is 4. It will be offset, and we're going to be changing this to in the future offset, so it's going to be at least that. And I'm actually going to put this a little bit further. We're going to put it 200 by 200, so it's kind of out of the way. And we'll change that later. Plus, and we need, so this is where it's tricky, because the right one is further away. It's going to be the bigger value. And the right button is 1. So when we have a remainder of 1, oh, this is wrong. If it's divisible by 2, that's what we want. And then we need to use I as well. So when it's the right button, it will be 1. And so we want 1 times, oh, how do we do this? Oh, I'm confusing myself. I'm thinking I'm making this harder than it needs to be. I think I'm just going to lay this out. Yeah, let's do that. So we're going to hard code each button. So if it's up, we're going to place it in a certain position. If it's right, we're going to place it in a certain position. So let's do up first. So zero up. It's going to be at the offset. It's going to be, yeah. Let's just put it right at the offset on its x. And then its y, then we're going to do a plus 0, because we'll need that for the other D-pad buttons. and its y will be at 0 as well. So that's going to be, or no. It's y 200, 200. No, it's y is 200. It's going to be the top. It's fine. Its x is actually going to be offset. So now that it's 8 by 8, I want, and we're going to have to play around with this. Let's do 10 pixels. So it's going to be above the left button, but to the right of it, a few extra pixels. We'll see what that looks like. Let's go ahead and do the other ones. And we're going to do else ifs on this. That will save us a few cycles if we do that. Nice. 1, 2, 3. Okay, so right is going to be 10 plus 2 is going to be 12 pixels. And then it's going to be 10 pixels down. Is going to be 10 pixels over. And 12, let's see here. I gotta draw this out. I need a piece of paper. This is gonna be 0, 0, and 10 down. Okay, this bottom one actually needs to be 2 pixels plus 8. It needs to be 20 down, and our right is go over 2, over 2. Let's see here, over. Oh no, we're already over 2. 10, and then 20. This is 20 as well. Let's see here. 8 plus 2 plus 8. This is, no, these are both 18. No, they're 20 because we want an extra 2 pixels padding. Okay, I think I got it. And this is, yes, that's correct. .605, error before, right there. Okay, this should give us a laid out D-pad. Well, we got one of them. Oh, I probably need to change values, yep. 1, 1, 2, 2 is putting them all in the same place, basically. That did not work as expected. Button sprite, XY, XY offset. Yeah, that should be working. In fact, it should be going through all the buttons and putting them there. So why isn't this working? Oh, that's why. There we go. We're only working with that once. There we go. There's our layout. Actually looks pretty good. I don't mind that. It should have done it for all the buttons, right? I times 4. Oh, button ID, yes. Ah. So this needs to be I, and this needs to be button ID. And this should move all of our buttons to the same place. Well, it did some of them. Why didn't it do all of them? I messed up something here. It did more of them, not all of them. It should be going through all 4 times 8, all 32 buttons, and putting them in the same cross pattern. That's what I'm expecting. And I'm going to have to call it a stream here in just a moment. But let's see if we can get this figured out. D-pad. I times 4. That's correct. Plus 4. That is correct. There we go. I should probably be verbose with the eyes. That would help out here. There we go. So now all 32 buttons have been stacked up on top of each other. So what we can do, I'm going to move this back over. We need to create an offset according to the controller. So we do offset, and basically we're determining the width of each box that represents all the buttons of a single controller. I would like to do a Y offset as well, which I guess we will be doing here soon. So if we do times, so offset actually, do we even, that's just the baseline. Plus, and then this is going to be the offset for each controller. So I times, we want to do 4. Let's just make it simple right now and do 80 pixels. We'll probably have to add another offset later on with that. But, well, we got to start. We need to do it to all the buttons. Copy, paste, like that. We might consolidate this. There we go. There's 4, and then we can do that also on the y-axis, which will do 60 pixels for that. This, again, this is going to be a little bit of a mess, but we should be able to get the idea. Let's set this offset to 16, like that. I just want to do 2 rows. Can I do that without doing another for loop? That's the question. I don't know if I can. What we can do, let's see here. Divide by, if it's need to create another I divided by, I think 4. Is that right? 4, no. 5. Because that will give us 1. Once it's above 4. I think that's what we want. We can definitely optimize this code later. It's closer. Let's see here. And I definitely want to do I. So when I becomes 5, maybe it is 4. 4 that turns into 1, and it will never hit 8. Huh. 1 times 60. So before that, it's 0 times 60, and that's fine, because we want it to be up here. And then $16 plus 10. Yeah, this should be working. Why isn't this working? This should become 1 times 60. Huh. And why isn't that laying out? Well, we may have to just call it a day for today. I gotta get to my day job. Anyways, I'll figure this out later. Maybe we'll do a little bit more of this tomorrow. We'll start off here and finish this off tomorrow morning. Last week we doubled up on Battlesphere, Battle Morph, and so maybe we'll double up on programming this week. Anyways, let me go back to my camera. Thanks for watching. If you're still here, I streamed a little bit longer than I usually do today. Tomorrow I'll probably do some more programming. That's what I'm feeling right now. So expect some more programming tomorrow morning. Again, if you aren't following me here on YouTube, go ahead and do that so you get notified of that. I'm also on Facebook and Twitter. There's links in the description. Anyways, I hope you enjoyed the stream. Let me know if you want to see anything specific. And we will see you tomorrow morning. Bye.